In today's experiment, we'll be determining the focal length of a convex lens. I've set up an optical rail. To the left on the optical rail is our light source. The filament in the light source will be our object. In the center of the optical bench is our convex lens, and the screen, which will form our image, is on the right of the optical bench. Notice that I masked off a portion of the filament on the top part of the light bulb. Other things I'd like you to note are the light bulb is centered at the 10 centimeter mark on the optical rail. Later on, we'll collect data noting the positions of the lens and the screen. The lens has a 2 centimeter offset to the left compared to the reading noted with the 0 mark on the rider. Right now the 0 mark is at the 48 centimeter position. The offset tells me that the lens is really at the 46 centimeter position compared to not where the light source is, but to the 0 mark on the optical rail. The screen is centered on the black tick mark. So you can see that right now the screen is at roughly 69.2, 69.3 centimeters. Okay. Here's our screen. Let's move the screen. And you can see an image starting to form, and then it gets blurry. Image forms and it gets blurry. So let's move this to the most in focus position. To me, this looks like the filament is in focus. Note where the masked off position of the filament is. Remember, the light bulb was masked off near the top of the light bulb. So let's get our numbers. Well, you already saw that the lens was at that 48 centimeter mark, but don't forget the offset. There's our new screen position. Let's move the lens and find a new image. I think I'll stop with the 0 mark on 53 centimeters. And now let's find the position of the best image. Right there. So we have a new lens position. And a new image position. So the screen is right now just shy of that 64 centimeter mark. Let's collect another data point. I'll move the lens. Now let's find our new image. Out of focus, focus, out of focus. Right there appears to be the best. Okay, where are we? Here's our lens. And our screen position. Let's do this again. We'll move the lens. And now, let's find our new image. Blurry, looks good, gets blurry, going back. That to me looks to be the best image position. Let's look at our numbers. The lens, and the screen. Okay, let's get a new image. Going back and forth, that gives me my best image. Let's collect some numbers. There's our lens. And our screen. I'm having so much fun, I think we'll collect a new image. So the lens is in its new position. Let's find our image. Wasn't focused, got blurry. That looks good. We're blurry. Just going back and forth, zeroing in. That is an in focus image. Let's look at our positions. There's our lens position. And our screen position. This is 80 centimeters right there. Let's do another data point. Get the screen out of the way. Let's move our lens and find our new image. Looked good, but now it's blurry. Looks good, now it's blurry. That looks good right there. Oop, too close. Camera doesn't like to zoom in too much. There's our lens position. And our image position. This tarnished mark right there looks to be the 5 millimeter position between 83 and 84. 83, 84. The tarnished long line is the 5 millimeter mark. And I think that's enough data points.